Yeah, in this video, we'll understand how we'll check the regression model and the model on the point multicollinearity. The multicollinearity is very tricky and its impact on the regression model is immense. So let us see how the multicollinearity effect in the regression model. To find out the effect of the regression models, this multicollinearity is, so let us find out. We have the data with the y as the dependent and x1 and x2 as the independent variable, and first step what we have to do, we have to draw the correlation table among all these variable, and we can do it easily by going to the data and go to the data analysis, and in the data analysis then whatever you want to do the correlation, you want to do the regression, that you will get a checkbox response, and in that checkbox you can go. Can you see here, the if you want to do the correlation, you can take the put the OK, and you can select the entire data set. Once you select the entire data set and you click on OK button, then here if I'll select it and you put the label, so that if you are including the names, then you put the output range wherever you want to, you can, and you click on the OK. So then it will show you the correlation output. So now this is the way we got the correlation output, and in the correlation output in this case, if all of you see, then we'll find here the correlation between the independent variable as lower than the independent variable correlation with the dependent variable. So y is highly correlated with x1 0.63, y is negatively highly correlated with x2 is 0.56, but x1 and x2 are low correlated. So in multicollinearity is to remember the independent variable should be highly correlated with the dependent variable. There should be low correlations among the independent variables. If this is the situation, then what we will find, that if I'll take the regression of y with the x1, so to do the regression also, what you can do, you can go to data analysis and you can go to the regression here, and you can put the OK, and you can put the y as the dependent variable from this column, and x1 as the independent variable from this column, and then you click on labels, and if you are if you are taking all the data along with the heading, then click on labels, then wherever you want to get the output range, you click that cell in that Excel, then you click on OK, then you will get the all the detail of the regression coefficient. And once you get the regression coefficient, what I found, the beta 0 is 1.67, beta 1 is 0.19, and this beta 0 is 5.39 and minus 0.22 in the yx2 case. And when I want to do the regression of y with the x1 and x2, I'm getting 2.43, 0.22. And can you see here, this is beta 1 is positive, here also it is positive, beta 2 is negative, here it is negative. And if there is a low correlation among the independent variable, so there is no issue of the multicollinearity, and we are getting, there is no such reversal of sign, and whole calculation we have done. And to understand the significance of the model, so if you see x1 and x2, their p-value is 0.002 and 0.004. All of both of them are less than 0.05. So both of them are significant in the model. So we need both x1 and x2 for the model. We understood the model significance. We understood the variable significance. We should also check the R-square value, and we need to check the and last the multicollinearity along with the error distribution to find out the feasibility of the regression model. So in the next example, I have taken the example from the Anderson book, the book Multivariate Data Analysis by the Hare, Black, and Barbin Anderson. Both these two examples I have taken from that to test and to justify the multicollinearity effect in the regression equation. Thank you. Whether this model is fit, we can see here affecting and significant variable for the regression model, and I got the R square and all about from this. So let us find out how we can go for the multicollinearity calculation. To multicollinearity, we got the significance of the model, we got the significance of the individual variable. Now let us see the multicollinearity calculation. To do the multicollinearity calculation, you have to take one of the independent variable as dependent variable, and other independent variables are the independent variable. So because I want the x1 should not be explained by x2, x2 should not be explained by x1. Rather, y should be explained by x1 and x2 together. So let us see how we can do by taking x1 as dependent, x2 as independent, or x2 as the dependent, x1 as independent. I calculate the r square. Let us see here. Can you see the equation here? X1 I got as the independent variable and x2 as the dependent, and I got the I see the r square. I check the r square, and this r square is 0.02, and this r square is also, as there are two variables, this is also same as the correlation square of the correlation between these two variables, that is 0.02. So once you get r square, to calculate the multicollinearity, find out the tolerance. 1 minus r square is equal to 0.98, and the VIF is equal to 1 upon tolerance. So 1 minus 0.2, that I got here, and 1 upon 0.98 tolerance is my BIF, that is the multicollinearity. So there is no multicollinearity, and remember, when there is no correlation, when the R square is 0 and your BIF factor is 1, means there is the model is absolutely free from the multicollinearity. So, and the multicollinearity can go up to infinite. So if it is more than 5, then you should reject the model, and in some of the cases even at 1.5, 1.10 also, 1. For more than 1.5 also, it start affecting your regression model. You should be careful about the multicollinearity, the calculation, the correlation, then the individual regression, then the whole model regression, or you can calculate the BIF directly through the SPSS. You need not to. I am just showing here for the clarity how we go about the calculation. Let us see the multicollinearity effect in the real life example with A and B, example A and B. So A and B example, example A, where y is the dependent variable, b1, b2 as the independent variable. I got the correlation here, the table, by going the data analysis, and can you see here the y is correlated 0.79 B1 and minus 0.97 B2, but B1 and B2 are highly correlated. This is my area of concern. B1 and B2 are negatively highly correlated. So if there is such correlation, high correlation among the independent variable, let us see the impact of it. So when I see the regression between y and b1, the regression coefficient 1.42 and intercept minus 3.63, and regression between y and b2, if I'll do, then minus 1.95. So you can take y as the dependent, b2 as the independent, we are getting. But when I'll take together y, b1 and b2, can you see the regression coefficient of beta 1, which is b1, used to be positive impact on the y, now it is showing negative impact. It is just because of the influence of the regression the correlation among the independent variable. Let us see how we can calculate the r square for this, and the BIF. So correlation among the B1, B2 I find minus 0.89, and the r square I am getting 0.80. If you do the regression also, the B1 taking B1 as independent and B2 as dependent, you will also get 0.80. You can experiment, and tolerance is equal to 1 minus r square, that is 0.191, and BIF equal to 1 by tolerance 5.2. It is because the BIF so high, it is having a impact on the regression coefficient of beta 1. So and you see this regression equation is really misleading. We saw initially the regression equation, b1 having a positive effect on the y, but in the multiple regression model, it is misleading that b1 having a negative impact on y. So it is under the influence of your multicollinearity, because of the correlation among the variable is very high. Similarly, I'm doing here, you can take this example and you can do of your one, and y and z1, z2 is given. I have taken, so the correlation table, can you see here the correlation between y and z1 is so low in comparison to the z1 z2 correlation, it is so high. So now if this is the problem, then I find out, I'll see the regression coefficient individually yz1, yz2, yz1 and z2. I can see again reversal of the regression coefficient of beta 1, the z1 to negative, and it is, so there is a multicollinearity. So I calculate the multicollinearity. I'm finding 1.49. Even at the 1.49 it is misleading. So 5 point more than 5 is absolutely rejected. More than 10 is critical of multicollinearity. In some cases also you can go through these steps to identify the multicollinearity and correct the multicollinearity. So correction is the different part, we'll see. And here I have taken when that is z1, z2, z3 as the independent variable and only y as the dependent in this case. To calculate, what you have to do, z1 you have to take as independent variable, z2 you have to take z1 as the dependent variable and z2 and z3 as the independent variable. Find out the r square. So by this process, to calculate the r square here for the multicollinearity, don't go to the original equation of dependent as y, z1, z2, z3 as the independent. From that r square if you calculate, it will not show. We want that my independent variable should not be explained by the independent variable, and r square measure the explanation, the variance explanation. So that's the reason I took z1 as the independent variable, z2, z3 as the independent variable, and this r square should be as low as possible to get rid of multicollinearity. And by taking that, I got the r square, and from that r square I'm finding out the 1 minus r square tolerance. Then from that I'm finding out the 1 by tolerance, that is BIF, and I'm finding 1.53. Similarly, to find out for the BI for the Z2, I have to take Z2 as dependent and Z3 Z1 as the independent variable. I find out the r square out of this, then tolerance, then my BIF. So this is the way the BIF calculation used to be done in SPSS. The SPSS output, you can directly see this output 1.8 or 1.53, but how it is calculated, this is the way the whole calculation done, and it is really critical. And most of the time people, students used to confuse with this calculation even after reading hundred of time in the book. So this is all about your multicollinearity calculation, and let us get rid of multicollinearity in future. And thank you. This of immense help in building your regression equation models. So what are the things you should check in the regression model? I told in the regression model you should check the model significance through the f and through the f value, and here the significance of the f, that significance value that should be less than 0.05. Then you need to understand the significance of the individual variable x1 and x2. Here the p value 0.05, 0.05. Here you can see the significance. Okay, the standard error I was seeing, but we can see the both p value are significant here, 0.02 and 0.004. So this is the way we can go about the whole multicollinearity calculation. Thank you. Thanks for your. So this is the way multicollinearity along with the significance